Hi everyone, this is my video number 22, right? So for this session I will talk on line integral in space. Line integral in space, right? I will explain to you what is the difference between this and the previous integral that we have integrate f dot dr. So let's see the definition for this first. The definition, let C be a curve defined by this position vector where r with component xt, yt and zt, where t in AB, and we let f be a continuous function, scalar function, continuous scalar function, defined at each point along C. Then the line integral, of f along C is given as we integrate C f ds. This is equal to integrate a to b f, a function of xt, yt, zt, ds. ds is given as then x prime t squared plus y prime t squared plus z prime t squared dt. Okay, so from the left side of the equation here we have ds. It comes to like that. Why it's become like that? So it's simply because but the definition of ds dt is actually the magnitude of dr dt. Okay, so you can write this as a ds as a dr dt dt, where the magnitude of dr with r given as that, this is your r. So if we differentiate this dr dt, we're going to have this is x prime, y prime, z prime, where prime is the differentiation with respect to t. Okay, then if we take the modulus of the modulus of dr dt, so what we're going to have is something like that. This is x prime squared plus y prime squared plus z prime squared t. Alright, so that's why you can see from the definition we have f ds. Now this is f, we just substitute everything with the function of t, and then the ds becomes that terms. Now before I go to the example, so let me explain to you what is the difference between this case, where in this case we have integrate c of f ds, with the previous one where we have integrate over c f dot dr. Are they the same? All right, so the difference is that in this case we have our f is a vector function, where the vector function is given as we have p x, y, z, pq x, y, z, and r x, y, z for the case of 3 dimension, where your dx, your dr is just your dr is dx, dy, dz. So if you can see from this definition, all right, so we have dot product because it involves 2 vectors here, f and dr. Okay, if you use this definition here, this term there, so what you're going to have, f dot dr is actually integrate over c p, instead of f dot dr, so we have p dx plus q dy plus r dz. Okay, so there's the integral. Whereas for this case, we have here f is a scalar function and ds here is also scalar, right? So that's the difference between that, okay, in space and as well as in the for the previous definition of line integral. Yeah, this involves 2 vectors. In this case, involve a scalar function. Now, let me give you a simple example on how can we use this. Okay, example. Let's say our C is given as RT as cos t, sin t, and t, where t belong to 0 to pi. Then we want to evaluate a function f of x, y, z given as x plus y plus z along C. Now, so basically what we want to do is we want to evaluate those f along C. What is this? Okay, so how do we do this? Look at the given arc here, or the curve C. So for each of these terms, each of these component, all right, so this is component for x, this is component for y, this is component for z. So I can write those components in terms of x, y, z. So we have x of t is actually first term there, cos t, y of t is sin t, and z of t is equal to t. Okay, so if you differentiate this, because this is r, we need the r. Okay, look at the definition. The ds is given as magnitude of dr dt. So in order to find ds, we need to differentiate the given position vector and find the magnitude. All right, so to differentiate those things means we differentiate each of these. So we have x prime is given as negative sine of t, y prime is cos of t, and z prime is 1. So therefore the magnitude of dr dt is given as, we have square root sine squared, negative sine squared, negative sine and squared. So we have sine squared there. This is negative, negative is positive, plus that one is cos squared, plus 1 squared is 1. That give you square root of 2. Now what about f? What about f here? So look at the definition again. Our f here we have to write the given f in terms of parameter t. Alright, we need to write f in terms of parameter t. So in this case, our x is given here, which is we obtain from the position vector. Alright, our y is given here, our z is given here. So we just need to substitute all this x, y, z into our function of f, x, y, z. So therefore our function becomes, so our f, x, y, z, this is just a minute, x, y, z is x plus y plus z, x plus y plus z. So if you want to write in terms of f of t, y of t, z of t, which means we need to substitute each of these x, y, z with the appropriate component given in the position vector. So we have our x is given as cos, so we have here is cos t, plus y is sin t, and z is t. Okay, so therefore integrate of f ds along c, this is equal to, we integrate over ds. Now we have changed ds into dt, so our dt, now f is given by that, so we have cos t plus sin t plus t. Alright, and ds is dr dt, where we have shown that the magnitude of dr dt is equal to, what is it, sec 2, right? Sec 2, yeah. So sec 2 d2. So we just need to substitute this value ds into that expression here. So we have ds here is equal to sec 2 dt, and the limit of the integration is given in the question, that t in 0 to pi. So therefore we just evaluate this integral from 0 to pi. So I think here you should have no problem to evaluate this. I just go directly to the solution. We have 2 square root 2 plus pi squared sec 2 over 2. Okay, you just evaluate yourself that one. Okay, so that's the example that involve line integral in space. Now I give you another example that I showed earlier, that f dr can be written in that form, f dx plus q dy plus r dz. How can we solve that kind of problem? Now let's see this example. Give you another example here. Okay, so we evaluate c y squared dx plus x dy. Okay, where our c is given as is a straight line from points -5 to -3 to 0, 2, and C is a curve given by x equal to 4 minus y squared from -5 -3 to 0, 0, 2. Now, before I describe to you what is the what the curve C is, okay, let me describe or let me explain what is this integral. So if you look at the definition or the explanation that I provided earlier, that from f dot dr here with f is with component p of x, y, z, q and r, and our dr is dx, dy, dz. Yeah, this is from r as x of t, y of t, z of t. Okay, and all this dx, dy, dz is actually the differentiation with respect to t. So if we use this f with p, q, r components and r with dx, dy, dz component, so what we have, that terms as this, I have explained this earlier. So we have that c, so this gives you p dx plus q dy plus r dz. Okay, now if you compare this general form with this particular problem that we are going to solve, they have a similar form. Alright, so we have y squared dx, here we have p dx, we have x dy, we have q dy, and for dz we have 0 terms there, so that one we have 0. So now how can we solve this kind of problem? Alright, now let me describe the path or curve C that involved here. Okay, if we sketch those points and try to sketch the path C, so if you look at this point, minus 5, 3, so you have minus x is minus 5, minus 3, let's say somewhere here, there, and another one is 0, 2, 0, 2 somewhere here, right? A point 2.02 here. So this is 0, 2, this is minus 5, minus 3. Okay, so for the first part here, part A, C is a straight line connecting these 2 points. So which means we have this line from that to that. This is important, from. So which means our direction is from first point minus 5 to minus 3 to 0, 2. Alright, if you look at the second part B, we have this equation. Alright, if you substitute there, what does it work? X and y, if x is 0, so yes, true. So what is this curve? So if you plot this, so you're going to have something like 4 here. So we have something like that. Okay, from minus 5 to, so that the direction of our integration. So this curve is given as x equal to 4 minus y squared. Now let us focus on how to solve this problem. We need to solve, since we have identified the required path. Now we go to how to solve this integral. We have y squared dx plus x dy. Now let us go back to that line from minus 5 minus 3 to 0 2 with the straight line, definitely you can find the equation of that straight line. Yeah, the equation of that straight line, you can find that. It's not difficult. You can find what v is, which is the parallel vector to that. You can find this thing v. So v is, what is it? So 5, right? 0 minus that 5, 2 minus that, so you got 1. So therefore the equation for that straight line, we have x equal to, you can choose any of those points, so I would choose that. Seems much easier. So z is 0, so we have 5t, and y equal to 2 plus t. I think you remember this. This is x equal to x naught plus t v1, y is equal to y naught plus t v2. This is general form of the equation of a straight line, or you can use y equal to mx plus c if you want. Now, having this in mind, alright, we just need to substitute each of these x, y into that function. Of course, we need to find what is dx, what is dy. So let me write it here. So we have x equal to 5t, y is equal to 2 plus t. This is basically our c. So you need to substitute not just y and x, we also need to substitute dx. So from there, you just differentiate respect to t. You got, this is 5 dt. Differentiate that, you got dy is equal to dt. Substitute everything there into the integrand that we have earlier. So that give us along c, our y is 2 plus t squared, and dx is 5t dt, plus our x is 5t, and dy is as dt. What about the limit? I'll explain to you limit a little bit later. Now let I'll simplify this. So we have integrate. What is this? This is, we have 4 plus 40 plus t squared times 5 plus 5t, and everything with dt. Okay, remember the limit here is a limit for t, because we differentiate, we integrate with respect to t. So the limit should be t. Now, in order to obtain the limit, you look at the point. We have from minus 5, minus 3 to 0, 0, 2. We may choose any of these. We may choose any of these, either x or y, depend on which one is easier for us to use. So probably if I use x is much easier, because both point minus 5, minus 3 and 0 to 2 for x and y, both are changed, right? X change as well as y change. So we have, when x is minus 5, when x, let's say we use this point, when x equal to minus 5, so you can use this, you can use that. So we have x is minus 5 is equal to 5t, that gives you t equal to minus 1. Okay, then when x is 0, x is 0, so we have use the same terms. Then we have 0 is equal to 5t, that gives you t equal to 0, which means our t is from minus 1 to 0. T from minus 1 to 0. So the limit of integration here is from minus 1 to 0. Do not change. Okay, do not make it, if you put it 0 to minus 1, then you get negative. Wrong answer. You must be careful with the choice of points. It must be from to 2. Alright, from to 2. Now you can evaluate this thing. Should have no problem anymore. So this is equal to, I think I just go directly to the solution. What is the solution? I have I don't have a solution. No, I don't have a solution. So you have. So let's try. Let's do this. -1 to 0. So we have 20 plus. This is 20t plus 5t. So we have 25t plus. You have 5t squared. 5t squared dt. Okay. So that's equal to, we have 20t plus 25 t squared over 2 plus 5t cubed over 3 t from -1 to 0, so that you have everything 0 there. 0 minus, put t is -1, so you have -20, t -1, so you have plus 25 over 2 plus this one is a negative, so we have -5 over 3. Then you can find what is the answer for that. I just leave it that part. Now, the first part here, we integrate through the straight line. Okay. Now let's evaluate using that curve. That curve is given for part B. The curve is given as x equal to 4 minus y squared. Remember that we want to evaluate c y squared dx plus x dy. Now how to do this? You can set one of the variable with the parameter t. For example, I can choose y equal to t. Let y equal to t. I can do this. Let y equal to t. Then I can have dy equal to dt. Or I can also do this from there. I can differentiate directly so that I can substitute there. So for this, we have dx is equal to minus 2y dy. So I can substitute that into that. So you can use this or that, either one. Okay. If you do this, then you need to substitute for x as well, since y equal to t. Therefore, we have x equal to 4 minus t squared. So we need to differentiate with respect to t. So we have dx is equal to minus 2t dt. Yeah. If you look at this with the parameter t, or we're using the variable x and y, we have basically the same terms here. Alright. So you can use either that one or that one. So let me stick to one of them. Let me just focus on that approach. Okay. If you focus on that approach, what happened to our integration here? Our c is for t now, y squared, since we have set y equal to t, so y squared, this is t squared. Our dx is minus 2t dt plus x dy plus our x is this 4 minus t squared, dy is dt. So then you can evaluate. Okay, and then for limit of integration, you can find, look at this, we choose y equal to t. For the limit of integration, we choose y equal to t. So you look at y, look at the point y, where is it? Here. Look at the point y from minus 3 to 2. So we have y from minus 3 to 2. So therefore our t from minus 3 to 2. The reason because y equal to t. Okay, now we put this limit into our integration, so we have t is from minus 3 to 2. Then you just evaluate that. So what you have, this is minus 2t cubed plus, I put it, minus t squared plus 4 dt. You just evaluate this, whatever answer you have. Definitely this answer is different than that answer. Okay, definitely this answer different than the second answer, second part, because we use different path. Okay, so I think I have to stop here. It's already half an hour, so I'll give you another example in my next video. Okay, bye bye.